All right, 8.3 part 1, we're going to be integrating functions that we weren't able to integrate before, something like 1 over x. It would have been x to the power of -1. We can't add because then we would get x to the power of 0. But now we can integrate it because it's going to be an ln function. So these are our rules. If we have the integral of 1 over x, our answer would be the ln of the absolute value of x plus c, if it's an indefinite integral. 1 over u would be the ln of u, so same idea. We're going to have to use u's. We'll have to use substitution here to help us. If we have the integral of u, of the derivative of u over u, again, that's the ln of u. And then if we have an exponential function, a to the power of x, our antiderivative, our integral, would be a to the power of x, but then we have to multiply 1 over the ln of a. So we're dividing by the ln of a. And all of these are plus c because they're indefinite integrals, but we'll practice some definite integrals as well. So let's look at example 1. We want to find the integral of 2 over x dx. Well, anytime we have a constant number, coefficient, we could just pull that out front. So 2 times the integral of 1 over x dx. Now this looks just like one of our rules. 1 over x, our antiderivative, our integral, would be the ln of the absolute value of x. But we have that 2 outside, so the 2 just multiplies out front, and then we can't forget the plus c. So the easiest type of question that we'll have here is just 1 over x dx, because we know that's just going to be the ln of the absolute value of x. So sometimes we might want to use substitution to get that 1 over x or 1 over u, because that's going to be the easiest thing to take the integral of. So here, I'm going to let u equal 2x minus 1. So what would the derivative of u be? 2 dx. So I can change that 2x minus 1 to be u. So I've got a u on the bottom. I need a 2 dx to replace the dx with du. So if I put a 2 in here, I also have to multiply by 1/2, keep it balanced. So now that 2 dx is going to be replaced with the du. So I just have 1 on top of my fraction and a 1/2 outside. Now what's the antiderivative of 1 over u? What's the antiderivative of 1 over u? What was the antiderivative of 1 over x? The ln of x. So here we'd have the ln of the absolute value of u, with the 1/2 being multiplied and plus c. Last step is we just want to replace the u. So we know that u equals 2x minus 1. So we need to replace the u. So we have 1/2 times the ln of the absolute value of 2x minus 1 plus c. Let's look at 3. Find the area of the region bounded by the graph of x over x squared plus 1 and the x-axis on the interval from 0 to 3. So when we find the area bounded by the region, we're looking for the integral. So the antiderivative of x over x squared plus 1 dx from 0 to 3. So from 0 to 3. Got a definite integral here. So let's let u equal x squared plus 1. So what would du equal? 2x dx. So I have an x dx up top, but what am I missing? The 2. So I'm going to multiply by a 2 up top. Now I've got a 2x dx that I can replace with the du. What else would I have to do? multiply by 1/2 on the outside. So I have 1/2 times the integral. I'm not going to put values on my integral because these are x values and I don't want to get confused when I'm plugging in u's, so I'm just going to leave it blank for now. 2x dx turns into du, and then x squared plus 1 would turn into u. So we've got 1 over u du. What's the antiderivative? What's the integral of 1 over u? ln u, perfect. ln of the absolute value of u. It's not plus c because we do know that it's a definite integral. So let's plug back our x's so we can find what our values are. So we have 1/2 times the ln of x squared plus 1 from 0 to 3. So what would we do next to solve? Which one first? 3. Plug in the one up top first. So we have 1/2 times the ln of the absolute value of 3 squared plus 1 would be 10, minus 1/2 times the ln of the absolute value of 0 squared plus 1 would be 1. We could simplify this a little bit more. What's the ln of 1? 0. Awesome. ln of 1 is 0. So this would go away. So we have 1/2 times the ln. We don't need the absolute value because there's no x's there. It's already a positive number. So you can just say the ln of 10 if you wanted to. That would be our answer. All right, let's look at 4. So I'm going to let u equal x cubed plus x, and du would be the derivative of that. So we've got 3x squared plus 1 dx. Perfect. That's exactly what we have here. So I have the integral of 1 over u du. So what would our antiderivative be here? The ln of u, perfect, ln of the absolute value of u plus c. So the last thing, we just want to plug back in our x's into the u. So we have the ln of the absolute value of x cubed plus x plus c. Three x squared plus 1 dx turned into du. Let's do b. So let's let u equal x squared plus 2x. So then du would be what? Two x plus 2 dx, perfect. So I can replace the x squared plus 2x in our denominator with u. But I don't quite have 2x plus 2 that I can just replace it. How could I change the x plus 1 that I do have and make it 2x plus 2? I can multiply by 2. I can multiply the whole numerator here by 2. That would make this 2x plus 1. 2x plus 2, sorry. So now we have a 2x plus 2 dx that I will replace with the du. But I can't just multiply by 2 out of nowhere. What else do I have to do? Multiply by 1/2 on the outside. Perfect. So what's the integral of 1 over u du? Ln of absolute value of u plus c, and then we just multiply that 1/2 on the outside. And the last step, we want to plug back in the x's. So we have 1/2 times the ln of the absolute value of x squared plus 2x plus c. Let's do c. So let's let u equal what? 3x plus 2. Then du would be 3 dx. Perfect. I've got a dx, but I need 3. So if I multiply by 3 up here, what else do I have to do? Multiply by 1/3 on the outside. Perfect. So now we can plug in our u's. We've got 1/3 times the integral of 1/u du. What would our antiderivative be of 1/u? Awesome. 1/3 times ln of the absolute value of u plus c. What's the last step? Plug back in the x's. So 1/3 times the ln of the absolute value of 3x plus 2 plus c. Before we look at number 5, there's this little note here. It says when the degree of the numerator is greater than or equal to the degree of the denominator, you have to divide first. So here it doesn't work out when we use u's, because if I made u x squared plus 1, the derivative of that is going to be 1 degree less. So it doesn't work out when your numerator is the same degree or higher. Bless you. So we want to divide first. What we're dividing is x squared plus x plus 1 by x squared plus 1. So we're doing a little bit of long division here. We've got x squared plus x plus 1 divided by x squared plus 1. So with long division, we always want to divide the first term by the first term. What is x squared divided by x squared? 1. Perfect. Then we multiply. We get x squared plus 1, change the signs, and combine. So we're just left with x. Can I divide x by x squared? No, can't take away 2 x's when we only have 1. So this would be our remainder. How we write our remainder is going to be a fraction. So we'd say plus x over our divisor, which was x squared plus 1. So this is the same thing as this, it just looks a little bit different. So we're going to take the integral of 1 plus x over x squared plus 1 dx. So when we take our integral here, I'm going to split it up into 2 parts. I'm going to take the integral of 1 dx and add that to the integral of x over x squared plus 1 dx. What is the integral of 1 dx? Awesome, x. If you want to, you could put x plus c here so you don't forget, or just make sure you include it at the end, plus c. Now let's do our second term here. I'm going to let u equal x squared plus 1. So what does du equal? 2x dx, perfect. I've got an x dx already, but I'm missing the 2, so I'm going to multiply by 2 up top. What else do I have to do? Multiply by 1/2 on the outside, perfect. So this is the integral of 2x dx is going to change to du, so 1 over u du. The 1/2 on the outside. So what's our antiderivative of 1 over u? ln of the absolute value of u, perfect, plus c, and multiplied by 1/2. Last step is we just want to plug the x's back in. So we've got an x from our first integral that we had here, plus 1/2 times the ln of the absolute value of x squared plus 1 plus c. So looking at number 6, I'm going to let u equal x plus 1. So then what would du equal? Just dx, or 1 dx. Perfect. So when I substitute everything in, I have the integral of 2x, or if you want to put the 2 on the outside, we can, over u squared du. I've got that extra x in there. How could I write x in terms of u? Awesome. We're going to solve for x in our u equation here, what u is equal to. We're just going to rearrange it and solve for x. So I can subtract 1 on both sides. So we get x equals u minus 1. So now I'm going to substitute this into my x. So we have the integral of 2 times u minus 1 over u squared du. Now there's different ways that we can solve this. If you want to pull the 2 out front, just leave it as a coefficient, you can do that. I'm going to distribute here. So I'm just going to show you this way, but again, you could do it the other way. That would work too. We have 2u minus 2 over u squared du. Now this doesn't really look more simplified than what we started with, but it's actually better for us when we just have one term in the denominator and multiple terms in our numerator. We can split up our fractions. I can make this the integral of 2u over u squared du minus the integral of 2 over u squared du. So just split up my fractions. We can simplify our first one, the u's cancel, so I've left with, I'll put the 2 outside now, 2 times the integral of 1 over u du. Now this looks like just what we've been doing the whole time here. Every other question that we've done, what's the integral of 1 over u du? Awesome. So 2 times the ln of the absolute value of u. If you want to put a plus c here so you don't forget at the end, you can. We'll just leave it there so we don't forget. Now let's do the second part. Again, I can pull the 2 out here. And then we're left with 1 over u squared du. Any ideas of how we could take our antiderivative here? What if we made this negative 2 times the integral of u to the power of negative 2? What would our antiderivative be of u to the power of negative 2? It's not like number 4 on the rules. It's like what we did way back when we started integration. How would we take our antiderivative? What's the rule here? What do we do? What do we do to the exponent? Add 1 to the exponent and then divide. Awesome. So when we add 1 to the exponent, we get u to the power of negative 1 divided by negative 1. So we can rewrite this a little bit better since we have that negative 2 being multiplied out front. -2 divided by -1 would turn into +2. So just to rewrite this whole thing, we've got 2 times the ln of the absolute value of u, then plus,
Please pardon the interruption. Will family students please come down to student services? Aiden Cardona. Jacob.
so I divided -2 by -1 and just move the u to the denominator since it had a negative exponent. What do you think the last step we have to do is? Plug back in the x's. We're going to substitute the x's back into the u's. So we have 2 times the ln of the absolute value of x plus 1 plus 2 over x plus 1 plus c. So this would be our answer.